A helicopter of mass 1000 kg rises with a vertical acceleration of 15 meter per second square. The crew and the passengers weigh 300 kg. Give the magnitude and direction of force on the floor by the crew and the passengers, action of rotor on the helicopter on the surrounding air, force on the helicopter due to surrounding air. So in the question it is given a helicopter of mass 1000 kg and the passengers of weight 300 kg are rising upwards with an acceleration 15 meter per second square. So the acceleration is in the upward direction, and uh, the first question they are asking is the force on the floor by the crew and the passengers. That means what is the force on this floor by the passengers? Because of passengers, what is the force they are asking? So that is nothing but the reaction force. So they will exert a force like this, and the equal and opposite force, that is reaction, will be exerted by the floor. So easily we can find it. We have to use this reaction force, and we are asked to find that reaction force only. That is equals to, we know F net is equals to mass into acceleration. What is F net here? So acceleration is in the upward direction, so we have to take r minus mg. So r minus mg equals to m into a, r equals to m into g plus a. So what is the mass we have to take? It is the force because of passenger, so we have to take the passenger mass of the passenger, that is 300 into g plus a is 10 plus 15. So this on solving we are getting 7500 Newton, and it is vertically downwards because the passengers will exert a force in this direction only. Like this they will exert the force, and the floor will exert a normal reaction in like this. So the passengers exerting the force on the floor means it will be in this direction, vertically downwards. And the second question asked is the action of rotor of the helicopter on the surrounding air. So now we have to consider the whole helicopter. Then the action of rotor, that means the force exerted by the helicopter of mass m and the passengers of mass small m. Okay, this is the capital M, that is mass of helicopter, and this is the mass of the passengers. So we have to take the force exerted by the helicopter of mass m and passengers of mass small m on the surrounding air. So if the helicopter, so if the helicopter is rising like this, or anyway, the force, their force, if this is the helicopter, then the force will be exerted on the air in this way. Okay, so it will be vertically downwards. Let us see what is that force. So that is m into g plus a because of helicopter, and small m into g plus a, that is because of passengers. So totally m plus m into g plus a. So that is 1000 mass of the helicopter, 300 is mass of passengers, g plus a is 10 plus 15. So this on solving we are getting 32500 Newton, and this is vertically downwards. Now the last question they are asking is force on the helicopter due to surrounding air. From Newton's third law, we know the reaction force R will be exerted by the surrounding air on the helicopter, and that will be equal and opposite to the force totally exerted by the helicopter and passengers. So what is this force? That is 32,500 Newton. So the same amount of force will also be exerted by the surrounding air on the helicopter, but in the opposite direction, that is vertically upwards. So this case, if we see, it is similar to the case of lift moving upwards with an acceleration a, and there we have found the effective or apparent weight as r, and we have said r is equals to the apparent weight, and that is what is measured by a weighing machine placed in the lift. And similarly here the reaction force is nothing but the force on the floor exerted by crew and passengers when helicopter is rising, and here it is the force exerted by helicopter and passengers on the surrounding air, and here the forces, the reaction force by the surrounding air on the helicopter. A body of mass m1 10 kg is placed on a smooth horizontal table. It is connected to a string which passes over a frictionless pulley and carries at other end a body of mass m2 of mass 5 kg. What acceleration will be produced in the bodies when the nail fixed on the table is removed? What will be the tension in the string during the motion of the bodies? What when the bodies stop? Try to solve this question. Let me know the answer. A person weighs 70 kg. He stands on a weighing machine in the lift which is moving upwards with uniform speed 10 meter per second, downwards with uniform acceleration 5 meter per second square, upwards with uniform acceleration 5 meter per second square. What would be the readings of machine in each case? What would be the reading if the lift mechanism failed and it falls down freely under gravity? So we have seen all the cases already. So now let us see the solution for these questions. So in the first case, they have given it is uniformly with a speed of 10 meter per second. So when there is no acceleration, then F net is just equals to mg. So that is nothing but 70 into 9.8, that is 686 Newton. Now second question is downwards with uniform acceleration 5 meter per second square. So when it is coming down with acceleration 5 meter per second square, then we know apparent weight equals to m into g minus a. Why? Because if this is the lift, mg will be downwards, reaction will be upwards, and it is coming down. So acceleration is in this downward direction. So F net equals to mass into acceleration, and that is equals to, that is m into a, that is equals to m into g mg minus r. So from this r will be equal to mg minus ma. So that is what is given, m into g minus a. So m is 70 kilogram and g minus a is 9.8 minus 5. So this is equals to 336 Newton. And when the lift is coming down, going up with the acceleration 5 meter per second square, then the apparent weight will be equals to m into g plus a. We have seen this case also, and that is 70 into 9.8 plus 5, that is 1036 Newton. And if it is freely falling under gravity, then see this case, m into g minus a, g will also be g, a will also be g. So the weight will be 0. The apparent weight or reading of the machine will be 0. So let us see this question. A nucleus is at rest in the laboratory frame of reference. It disintegrates into two smaller nuclei. Show that the products must be emitted in the opposite directions. Now, let m1 and m2 be the masses of products of disintegration and v1, v2 be the respective velocities. Then the total linear momentum of the system after disintegration is m1 v1 plus m2 v2. Suppose this is the initial nuclei and it is splitting into m1 and m2. Then if its velocity is v1 and if its velocity is v2, initially it is at rest, so its velocity must be 0. So the total initial linear momentum will be 0. So after the disintegration, it is m1 v1 plus m2 v2. And we know by the conservation of momentum, that is momentum initial is equals to momentum final. So m1 v1 plus m2 v2, that is momentum final, must be equal to momentum initial, and that is equals to 0. So if this is the case, m1 v1 plus m2 v2 equals to 0. So from this we can write v1 equals to minus m2 by m1 into v2. And since v1 and v2 have opposite signs, the two parts fly off in the opposite direction. So as they are having the negative sign, so v1 is negative minus sign. So there is a minus sign, there is nothing but they have having opposite signs, so they will fly off in opposite directions.